Good morning, students. So we talked about force in the previous video, and in this video we are going to talk about a brand new topic, that is pressure. Okay, you have obviously heard about the pressure, but you don't know what the actual meaning of pressure is and how it is related to force. So first of all, what we studied in the previous class was that what is force, and we also saw what are the changes a force can do on an object. We talked about what type of changes it can do, all the 4 points, and then we also saw different types of forces, that is contact forces and non-contact forces. So two types of forces we saw, and in that we had the examples of contact forces and non-contact forces. We even saw the definition and understanding of the different types of forces and why they are contact forces or non-contact forces respectively. But now let's talk about a new topic, that is pressure. Okay, we have already talked or seen about this pressure in a few cases. For example, you talk about the pressure in pressure cookers, and you can say liquid pressure or high pressure, low pressure areas. You have seen about that or talked about in geography probably. And we talk about this high pressure and low pressure regions in the previous standard, that is 7th standard, when we talked about winds, storms and cyclones, about high pressure region and low pressure region, if you remember properly. But now we will understand it even in more detail. So what is pressure? So a simple definition is a force which is applied on a unit area of a surface of an object is called pressure. So pressure is nothing but a force applied on a unit area of the object. Suppose this is the surface and I am applying force. Now that force is applied on how much area? And that force is applied on how much area is known as pressure. So for example, I have a small area, that is the edge of the phone. I am keeping it over here and I am applying force with this book. So I applied the force. But you can see there is no effect on the book. But if I use a pen like this and apply the same force, okay, and I apply the same force, you can see that there is a small change on the surface of the book. Now why is that? It is because the area of the surface is changed. Now applied the force, I applied the same force first with the phone and then with the pen. But because there is a difference in the edge, you can see this is the edge, or this was the area on which the force was applied, and next time this was the area on which the force was applied. As you can see, force was the same but the area changed. Now what happens is, when the area gets smaller, pressure increases. So in the first case, I applied the force with the same book, but the area was more. So there was no pressure change on this surface. Now next time I change the area, so the pressure was more, and hence you can see a small dot that pierced the refill into the page. So that is pressure. More force applied, or the same force is applied but the area is changed, then the pressure increases or decreases respectively. So according to this, we can give the formula for pressure. Pressure is equal to force on area. So if the force remains same, then the pressure changes because of area. A simple example, let's say we have applied a small force of 100 newtons. 100 newtons. Force is measured in the unit called newtons, and we have the area of small, let's say 4 centimeters. We have the area of small 4 centimeter square. So what we get, simple answer is 100 upon 4, so we get 25 newtons per centimeter square. Simple calculation. But if I change the area, if I make the same force once again, 100 newtons, and this time area is 2 centimeters square, then what I get is 15 newton per centimeter square. So the area has changed and so is the pressure, and that is why when we change the area, pressure also changes. Now this is the reason your mother is unable to cut vegetables with a blunt knife than with a sharp knife. So the blunt knife is like this scale, which doesn't make any much difference, but if we make the edge sharper, then the area of the edge is even smaller, and that is why even with smaller force it is easier to cut the vegetables. I hope it is clear. Now we will see some examples where this kind of changes occurs. Examples. Everybody has seen a nail which we can use with the help of a hammer to make a hole inside a wall. This is how a nail looks. This is the sharp end, and we apply the force over here with the hammer. So when we apply the force with the hammer, the nail gets all the force, and all the force is transferred on this small point, and this is your wall. So the pressure on this point, is more. If you apply the same force in the opposite, suppose the nail's head is on this point and you are applying the force, so you are applying the same force, but this time what happens is, if the point is not sharp enough, I'll give you another example. We have one more nail. Let's say this is a nail and this is the point. As you can see, the point is much more blunt. It is having more area and this point is less area. So even if you apply the same force, what happens is that force gets distributed over here. It gets spread out, and therefore the pressure on the wall is less. If the pressure on the wall is less, then the wall does not experience more pressure and the nail doesn't go through the wall. So if the pressure is less on the wall, then the nail doesn't go through. So if the pressure is more, and for that we require the point to be sharp, and that is why if the pressure is more, the nail easily goes inside the wall. The same example can be experienced when you visit a doctor. A doctor's syringe is, as you know, is having a very sharp point. So that sharp point is made for a purpose, so that it can easily go through our skin without making much more difficulty. So if the point is not that sharp, if the syringe is not that sharp, then you will face even more difficulty while pushing the needle through the skin. So if the point is sharp, then doctor doesn't have to apply more force and you feel less pain. But if the needle is broad or it is not that sharp, then the doctor has to apply more force and therefore you experience more pain. So it all depends on the point of the syringes, and that is why the syringe have a very sharp point. You might have also experienced this while using pipes or watering the gardens. Anyways, if you have used a pipe, when you place a thumb in front of a pipe, the water goes even more distance or a larger distance than before. It's because the point from where the water comes out, you have decreased the area. So the area is smaller, but the water force which was coming out, it is the same thing. So the pressure is now more, and therefore the water which is coming out from the pipe is traveling a more distance than before. So what did we learn today? So we learned today a new point, that is pressure. What is pressure? It is simply a force applied on a unit area of a surface of an object. Now pressure, according to that, can be defined as force upon area. Force upon area. An example, if we are applying 100 newtons of force on an area of 4 centimeters square, then The answer is 25 newtons per centimeter square. But if we decrease the area, that is 100 by 2, so 100 newtons is the same, force is the same, but we decrease the area, so the pressure is now 15 newtons per centimeter square. So as we decrease the area, pressure increases, and as we increase the area, pressure decreases. Now this was the examples for increasing the pressure. Let's say what are the examples for decreasing the pressure. In 7th standard, you also studied about the adaptations of animals according to the climate and weather. You have seen the adaptation of camel. What is the adaptation of camel? It is called sheep of the desert. But the most important one is that it can walk on sand without having much difficulty like us. So for that it has padded hoofs. You know about camel. Their hoofs are padded. So even though they are a larger animal with a heavier body, their area, the legs and the hoof, they are more, and because of this the area of the hoofs is more. So when the whole weight of the body is on the hoofs, it does not have that much pressure on the sand. On the other hand, if we are trying to walk on the sand, our area of legs is smaller compared to that of the camel, and therefore even though our body is smaller, the pressure on the sand is more, and therefore our body gets immersed, or our legs get stuck in the sand, and we have to pull them out quite hard. That is why a camel has padded hooves, so that they can easily walk on sand without getting their legs stuck in sand every single time they take the step. Okay. On the other hand, if you have seen, the bags that you carry to the school have broader handles. The handles of the bags are broader because when you hold the bag on your shoulders, the weight of the bag is getting pulled down on your shoulders. So the weight of all the books and all the stuff that you're carrying in your bag gets stuck on the shoulders, and because of which you feel pressure on the shoulders. That is why the straps on the bags are broad, so that the area is more than the pressure on your shoulders is less. So if the area of the straps of the bag is more, then the shoulders get less pressure, and if the area of the shoulders is less, if the area of the straps on the shoulders is less, then the shoulders feel more pressure. So in short, we can describe a mathematical formula based on this. Pressure is inversely proportional to the area, which means that when area increases, pressure decreases, and when area decreases, pressure increases. Okay, so we just found out the formula for pressure, which is force upon area. Now we have the formula, but how to solve it? We need to have the value of force. We need to have the value of force. The value, or a number slash numerical value, that describes a physical quantity, is called a magnitude. Now this is a long definition, but I will give you a simple explanation. In the previous example, I told you that the force is 100 newtons. This value in physics is called a magnitude. This is not a number. This is not mathematics. This value is called 100. That 100 number is actually magnitude. Suppose you have a weight of 40 kg or 50 kg. So the weight, that is 50 number, that 50 number is actually a magnitude with which you describe a physical quantity, and that is your weight. So the number which describes a physical quantity is called magnitude. In this case, the force is described by a number over here, and its unit is Newton. So the SI unit of force is Newtons, and SI unit of pressure is Pascal. So the SI unit of pressure is Pascal and SI unit of force is Newtons. So this is how you describe a number. So number is not actually called a number or numerical value, it is called magnitude. I hope it is understood. Let's say that this book is having a distance or a length of 16 centimeters. Then that 16 number is describing the length, and length is the physical quantity. So that 16 is actually the magnitude. I hope it is clear. Okay, we will describe once again. Pressure, a force applied on a unit area of a surface. A force applied on a unit area of a surface of an object is called pressure. According to the formula, force upon area is called pressure. We saw different examples regarding the knife and the nail. If the area is less, then the pressure on the wall is more, and therefore nail is easily able to go inside the wall. In the same way, doctor's syringe is quite sharp and very thin, so that it can easily get pierced in the skin, and that is why it is also easier to cut the vegetables with sharp knife instead of blunt knife. Okay students, I hope it is understood today, a new topic. We'll talk about another topic in the next video. Till then, goodbye.